now we're going to take a look at the second part of our slope-intercept form, lesson 4. Okay, part 2. Okay, so on the paper that you got at the beginning of class, the top section has the got it problem. Make sure you get that done. Try that on your own. I'll have the answer and work up on Erasma, so you can check that with the top section. If you look right below, it says when an equation is in slope-intercept form, when an equation in slope-intercept form applies to a real-world situation, the slope represents the rate of change and the y-intercept represents the initial value. Okay, so again, when an equation in slope-intercept form applies to a real-world situation, the slope represents the rate of change, the y-intercept represents the initial value. This is very, very important. This entire time, the y-intercept has been kind of your starting point when you're given an equation and you have to graph it. It's where we start. You plot the y-intercept, you use the slope to find the next point. In a real-world situation, the y-intercept represents the initial value. Okay, so make sure in your notes you circle this part. This is always our starting point. Okay, so let's take a look at example 4. Student council is selling t-shirts during Spirit Week. It costs $20 for the design and $5 to print each shirt. The cost y to print x shirts is given by y equals 5x plus 20. Graph y equals 5x plus 20 using the slope and y-intercept. Okay, let's stop for a second and see what's happening here. Now, in this example, they give you everything you need. But in the problems, you're going to have to figure this out yourself. So let's kind of break down what's happening here. Just a little reminder, the y-intercept is the starting point. In word problems, you can also, depending on the situation, it could also be the initial cost. The initial cost, distance, speed, so anything that's at the initial, okay? So the beginning, it's where everything starts. So if you look at this, no matter what happens with the shirts, it's going to be $20 to design it no matter what. So that's my y-intercept, because that's the starting value. So whether I have one shirt or 1,000 shirts, it's going to cost me $20 to get any shirts made at all. And then the minute you start seeing each is a big clue that this is our slope. Okay? So anytime you see, so for the slope, anytime you see each or per, okay, that's a clue that you're looking at the slope, because that's your rate of change. If it's $5 for each shirt, then that means one shirt is $5, 2 shirts is $10, 3 shirts is $15. That you could create a table with that's the pattern that would help you create the table. Okay, so this is our pattern or a rate of change. Okay, this over here on the side, I'm not asking you to write anything else on the sidebar. This right here, definitely write that. Okay, so let's take a look at what they did in the problem here. Step 1. Find the slope and the y-intercept. Okay, so this is where we have to identify our slope is 5, our y-intercept is 20. Graph 0, 20. Now if we take a look at what's happening on this graph, this is the number of shirts, and this is the cost on the y-axis. If we look at our starting point, 0 shirts is going to cost $20. That is true. 1 shirt costs $5, so my total is $25. 2 shirts will cost $10 plus that $20 that we had to do at the start. You don't do the $20 every time. The $20 is done once, and then from there you add the shirt cost. 5 shirts would be at $5 a piece. 5 shirts would be $25 plus that initial $20. That's how we get the $45. Okay. As for our slope, as we go up $5, we run $1. Something to be careful of on these type of graphs is don't take for granted the way these intervals are set. Our slope of 5/1 doesn't mean you go up 5 tick marks. It means you go up 5 units. If you look at our graph, our y-axis, let me make room here. My y-axis has an interval of 5, 5, 5. So be very careful in these instances. Make sure you understand how the intervals are set up. Doesn't mean tick mark, it means units. So pay very close attention to how the units are set. Okay. And then step 3, we use the slope of 5 to locate the second point. So if we take a look at what they did exactly, let me show you here. We started at $20, that's our initial value. My slope is 5/1, so I rise 5, run 1, there's my next point. Rise 5, run 1, next point. Okay, and then connect your dots for the line. Another side note is you would not have any points to the left because you can't have negative numbers of shirts. So this is also a case where you've got to pay close attention to the situation to know whether that line extends backwards or not. Okay. Interpret the slope in the y-intercept. If you look at number 5, number 5 says, the slope 5 represents the cost in dollars per t-shirt. The y-intercept 20 is the one-time charge in dollars for the design. Okay, so they're just talking you through the words of what's happening here. 5 is the cost per shirt. Intercept is 20. That's the one-time charge. Okay, so let's see if you got it. A taxi fare can be determined by the equation y equals 0.50x plus 3.50, where x is the number of miles traveled. Graph the equation, interpret the slope in the y-intercept. Okay, so x is the number of miles traveled. Okay. So if we look at this part right here, 0.50x tells me if x is the miles, 0.50 is my speed. Okay. Y-intercept is 350. That's going to be my starting point. So if it's half of a whatever per mile. Okay. Oh, taxi fare. It's a price per mile. It's not my speed. I'm sorry. I need to read the question again. 0.50x is the price per mile. 350 is the starting point. So this would be like the taxi fee. Okay. So if I were to graph this, I would start at 350. And for each mile, I go up 1/2. So I would go up 0.5 over 1, and there's my next point. Now, my graph is kind of little, so you're going to have to be very careful on yours. But for each half mile, I go rise is 50, run is 1. Okay. So for each half, 50 cents is for a mile. 50 cents is for a mile, 50 cents is for a mile. So what you're going to end up doing is getting a line that looks like this. Okay, so we graph the equation, interpret the slope. So what we have here is it's 50 cents for each mile. And 350 would be like the taxi fee. Okay, the next part is a guided practice. Take a look at the questions, try it yourself, and I will post the answers after you hit pause, and then I'll post the answers, and you'll see those next. Okay, so let's take a look. Liam is reading a 254-page book for school. He can read 40 pages in 1 hour. The equation for the number of pages he has left to read is y equals 254 minus 40x. I want to make a little side note. Up to this point, we have seen our equations written in y equals mx plus b format. They wrote this a little bit differently. It's very simple to rearrange this into the format that we need, if this helps make more sense. I'll explain why they did that, though. Okay, what we have here is the reason that it's minus 40x is because as he's reading, or we're kind of working backwards. The book is 254 pages, and each hour I'm going to subtract 40 pages because that's how many pages I've read. So after an hour, I'll be down to 214 pages. Okay, so if we were to make a table, so I start with 254 pages. After an hour, I go down 40 pages, so I'm down to 214. After 2 hours, I'm down. So you can kind of see how why we're subtracting the 40x, because I'm taking away pages as he's reading. Just so you know, okay? Tells us that x is the number of hours he reads. So state the slope and the y-intercept. So just because they're in this order doesn't mean anything different. Anytime you have a number multiplied by an x, so the coefficient of x is always the slope. Let me make this look a little more clear. The coefficient of x is always the slope. So my slope is going to be negative 40. The reason it's negative is because I have a minus 40. Okay, the y-intercept is the number that's the constant. Constant is something that doesn't change. Okay, this number is going to change here because I'm multiplying by x. 254 is always going to stay 254. So my y-intercept is 254. Okay, graph the equation. So we're going to start at 254 pages, so just do your best with this. Let's say right about here. Oops, that's not 254. So 254 might be somewhere here. Let me zoom in. Okay, so let's say 254 is right about there. And I'm going to read 40 pages per hour. So I'm going to go down 40 over 1 hour. Down 40 over 1. Down 40 over 1. So it's going to be about like this. Okay? You'll be you'll try to be a little more precise than I was. It's a little bit difficult to draw on this. But that's the gist of what your line will look like. Interpret what the slope and the y-intercept represent. They're just asking, what does that mean? The slope is negative 40. What does that mean? That means he reads 40 pages per hour. Okay? And then the y-intercept. A y-intercept is our starting point. Because that's our starting point, he starts with 254 pages to read. Okay? All right. Next one. Write an equation in slope-intercept form for the graph. So step 1 is find. So first we're going to find the y-intercept. And then find the slope. Okay? So my y-intercept is where the line crosses the y-axis. So my y-intercept is negative 6. For my slope, I'm going to take the first point and the second point, and I'm going to find the rise and the run. My rise is 4. My run is 3. So my slope is 4 over 3. Take those two pieces of information and write your equation. Y equals 4/3 x plus negative 6. Or y equals 4/3 x minus 6. So again, find the y-intercept. That's your b. Find your slope. That's your m. Now the next number 3 is an open-ended, your own opinion kind of answer. So do that one on your own, and that's it.